All right, 6.4, we're dealing with rational exponents. So all of the stuff that we're doing in 6.4, we have done, and it was actually on your quiz. So it's kind of just a refresher. So if the nth root of a is a real number, m is an integer, and m over n is in lowest terms, then a to the 1 over n is equal to the nth root of a. So whatever your number is on the bottom here, this is your index. That's that number that goes out front, and that tells you how many of a kind you have to circle once you break it down. So whatever is on the bottom is your index. So here we have an n on the bottom. This is our index. The number on the top stays up top, and it can either stay up top under your square root or outside the square root. So these mean the same thing. This nth root of a to the mth power, or the nth root of a all to the nth power. So these are the same thing. Yeah, my pencil still doesn't work. Same thing. So let's do some examples. Here, if we want to change these to be radicals instead of exponents, what would we do? What's 7 to the 1/2 power? The square root of 7. So we have the square root of 7 times the square root of 7. Do we have the same index here, the same radical? So can we combine these to 1? Yep. So we would have the square root of 7 times 7. So when your radical is the same, you can combine.
Miss Carter?
Yes.
Amory says she's having internet problems.
Okay, no problem. So we have the square root of 7 times 7. Can we break down 7 anymore?
No.
No. We want to circle groups of what here?
2.
Groups of 2. Do we have 2 of a kind here?
Yes.
Yeah. So we would circle our 2 7s, and then what comes out?
1 7.
Just 1 7. That's our answer. The 1/2s turned into the square roots. So our index is on the bottom here. So that means whatever this number is, that goes out front. And remember, if it's a 2 as your index, you don't have to write it.
Why didn't we multiply the 7s by 7s?
Because when your radical is the same, you multiply the insides together and combine it under one radical. So this is 7 times 7 here. But instead of multiplying them together, we just left it as 7 times 7 because we were going to break it down anyways and circle our groups. Let's go to example 2. So if we wanted to change this to a radical, what would our index on our radical be? What's that little number that goes out here?
4.
4. Remember, whatever's on the bottom is our index. So we have the 4th root of 5 times the 4th root of 125. Do these have the same radical, the same index? Yeah, so can we combine them together? Yep, so we have the 4th root. We put everything under the same radical. So 5 times 125. We can either multiply these together. We're going to break them up anyway, so we don't need to. So 5 We don't have any factors of 5, so we're just going to drop that down. What are factors of 125? 25 and 5. What are factors of 25? 5 and 5. Here we want to circle groups of how many?
4.
Groups of 4. When you're circling your groups, it has to be 4 of a kind. That was a common mistake on the quiz. People just circled 4 of anything. But it has to be 4 of the same thing. Do we have 4 of the same thing here?
Yeah.
Yep, we have 4 5s. So when we circle, how many 5s come out?
1.
Just 1. So whatever you circle, just one of those things comes out as a whole number. Do we have anything left on the inside? Anything we didn't circle?
No.
Nope. So our answer is 5. Here are exponents on the inside. So this is like saying the square root of 7x times 7x times 7x. Does this look like the last one we just did? Yeah, it's exactly the same after this first step that we did. So I'm just going to put all of my numbers together. So 7 times 7 times 7 and x times x times x. What am I circling here? Groups of how many?
3.
Do we have a 3 as our index out front?
2.
Nope, there's nothing out front, so we circle groups of 2. So I have 2 7s. What else can I circle? 2 x's. What comes to the outside? A 7x. And what stays on the inside? A 7x. So we get the same exact answer that we got in the last one. The only difference is that last question was written as the square root of 7x cubed. So it doesn't matter if your exponent is on the inside or the outside, you'll end up with the same thing. All right, so here we have the square root of 7x to the third power. So this whole thing on the inside is cubed. So this is like saying square root 7x times square root 7x times square root 7x. Do all of these have the same radical? Can we combine them together? Yep. So this would be the square root of 7x times 7x times 7x. Now whenever we have numbers and variables, we just want to work with our numbers and then work with our variables. So I'm just going to rewrite this as, if my pencil works, there we go. 7 times 7 times 7 times x times x times x. So I just reordered it because I want to only deal with my numbers at first. And then I'll deal with the x's. I need to circle groups of what here? Groups of 2. When nothing's written outside, remember it's implied that it's a 2 out front. So groups of 2. So I have 2 7s that I can circle. What else can I circle here? 2 x's. Can I circle anything else?
2 x's.
I already did that.
Oh.
No, I don't have 2 of a kind of anything else, so I can't circle anything else. What's going to come to the outside?
7x.
7x.
A 7 and an x, so 7x. What stays on the inside? 7x. And that's our answer. Yes.
So for the circled ones, do we put that on the inside of it?
The circled ones go on the outside. So this went to the 7, turned into that 7, and the x turned into that x. So if we change this into a radical, what number goes out front?
2.
2. The bottom is your index that goes out front. What stays on the inside is everything on the inside, so 64n to the 4th power. And then that number up top can stay up top. That'll be the last thing that we do. So let's simplify inside of our radical here. Well, what are factors of 64?
8 and 8.
8 and 8. Can I stop here, or should I keep breaking it down? I could stop because I already have a pair. I could also keep breaking it down. So it's up to you. If you want to keep breaking it down into 2's, you can. But I see I also have a pair right now, so I can just circle those 2 8s. How many n's do I have here? 4. So I have n times n times n times n. How many am I circling? Groups of 2. So I have 2 groups that I circle. What comes to the outside? 8n squared. So now I have 8n squared cubed, because I can't forget about this cubed here. So this is like saying 8n squared times 8n squared times 8n squared. Cube just means that I multiply it, whatever it is, 3 times. So I have 8 times 8 times 8. What's 8 times 8 times 8? It's a big number. Because 8 times 8 is 64, and then 64 times 8 is 500.
512.
Perfect, 512. And then how many n's do I have here? Not 3. Because remember, n squared is n times n. And then n times n, and then n times n. So how many do I have total? 6. So n to the 6th power. That's my answer. All right, example 6. We saw one exactly like this on the quiz. There's 2 different ways we can solve this. What is one way?
N times n 8 times.
So we have n times n. 4, 5, 6, 7, 8. And then what do we do? Perfect. This is our index, so that goes out front, so it's like the square root of n 8 times. And whatever our index is, we circle groups of that number, so groups of 2. So we have 2 n's, 2 n's, 2 n's, and 2 n's. So what comes to the outside? Awesome. 4 n's, so n to the 4th power. And that's it. So that's one way we can do it. Another way, which I noticed people did it this way on the quiz because we talked about it, is we can multiply these 2 numbers together. When you have an exponent raised to an exponent, you can just multiply them. So this is n to the power of 8 over 2. How can we simplify 8 over 2?
Divide.
Divide, so it's 8 divided by 2? 4. So we get n to the 4th power. Same thing, just 2 different ways of doing it. So you can either multiply your 2 exponents or just write it out.